If you measure an angle using a protractor, what is the SI unit for this measurement? And is it a base unit? What are the dimensions of an angle as a physical quantity? And so, like I said earlier, I have here the three kind of base dimensions that we're going to be using a lot this semester. So I could look there. Maybe, well, I don't know. I'm not sure if there's an answer there, right? Maybe it's in one of the other more exotic ones, but if you recall the other four that were there, most of them had to do with other kinds of things, not really geometry, so to speak. And an angle, I think, surely has something to do with geometry, which might be most closely related to length in some way. But clearly, you don't just measure an angle with the length. Although, I don't know, maybe from a certain point of view you do, right? Because if you have like a unit circle, right? If you say, hey, I've got like, I don't know, let me draw a little circle here. If I've got a unit circle, I'm not very good at circles on this thing either, but if I got a unit circle and I say, okay, let's just take like some section of that and say there's an angle, right? But if this is really a unit circle, and if I say these are two like radial lengths, and if I imagine that that's the center right there, and that this corresponds to whatever, I don't know, maybe I just put a question mark there for the angle. But there is a certain unit in trig class, right, that actually corresponds to an arc length of this circle. So that may be a little bit of a clue. But that usually that's the radian measure, right? So maybe what I'm suggesting, so that, in that sense, if we look at like what could possibly answer the first question, like maybe radians, right? Maybe the radian unit is the correct answer. So maybe I'll write radian here. Hopefully I'm spelling that correctly. But what else could it be? Could it have been degrees, right? I mean, but really radian is the one that somehow maybe corresponds to an arc length. But this only works for a unit circle. What if this instead had been like a circle that had like a radius r here? So this would also be a radius r. Pardon me, that first r didn't turn out so great. And in that sense, the arc length here, commonly in trig class, might be s. And there's a formula in trig that says that arc length is equal to radius times the angle measured in radians. This has to be in radians. In degrees, this wouldn't wind up working. And it kind of makes sense because if this angle corresponded to, say, a whole circle, that would be a radian angle of 2 pi, and that would correspond to the circumference of the circle for the arc length, and you just get r times 2 pi, which is the same as 2 pi r, which makes sense. So that's one way of connecting to this formula. And maybe I can answer this question about, like, well, what's the deal here? Well, so there's something that maybe is a little bit of knowledge I need to add to this, and that is that the radian, it turns out, is actually acknowledged within the SI system. Like, there is a document that says the radian really is a unit, but it is not a base unit. And so to help us kind of understand why it cannot be a base unit, if I solve for theta in this equation right here, I think I would get, divide r on both sides. I'm just getting back from about a week break since spring semester here, so I'm getting a little rusty on my algebra already, I guess. But anyway, I think theta is equal to s over r. And the way we can think about this is a length divided by a length. So in terms of dimensions, length divided by length, length over length, that really is kind of like length canceling length, right? That would be like no dimension. So that doesn't really correspond to a base unit. And it also kind of answers the third question here. So is it maybe I'll just say radian is my first answer. My second answer is no, it's not base unit. I'll put some commas here, I think, to make that clear. What are the dimensions of it as a physical quantity? And I'm going to say it is dimensionless. So let me see if I can squeeze that in here. I'm at the bottom of my pad again. Dimensionless. Okay, hopefully that's somewhat legible. So those are my three answers there. Let's see what it says. And there it is. The radian is the SI unit for angle. So like I said, it is acknowledged by SI to be an actual defined unit. I think it was only like in the 90s or something like that, early 90s, that they actually did that. Before that, it wasn't even acknowledged, but at some point they decided it was worth acknowledging. I actually kind of would have maybe preferred if they left it alone and not done that, because since the radian unit is dimensionless, it turns out we will see sometimes when you're doing kind of a units analysis of equations, we do that sometimes in physics, and the radian is kind of annoying because of its dimensionless nature. In that sense, like if you look at this equation, s is equal to r theta here, this is length is equal to length times radians. It's almost like the radian shouldn't even be there, if you see what I mean. So that's why I often thought, like, well, why don't we just not even have it? But the SI people have defined it, so we're going to use it, or we can use it. But it's like it magically disappears sometimes, and I've seen that happen in trig books too. So that's unnerving. But we'll see some other examples, I think, with that. Anyway, so there it is. It is officially a dimensionless derived unit.